equilateral triangle, draw an altitude and calculate the length of the altitude. So equilateral means all the sides and all of the angles are the same. And it says draw, so we don't actually have to construct this. We can go ahead and just draw. And remember that an altitude gives us a perpendicular bisector, and it cuts these angles in half. So this angle and this angle are congruent. And if I cut that angle in half, it used to be 60. That makes them both 30 degrees. And of course, this is 60, and this is 60. And these are both 90 right here. So we have 30, 60, 90 triangles. And we're going to discover how these are special and have a shortcut as well. So let's go ahead and say that this is 5 and this is 10. How can we find this unknown value right here, the height of the altitude? So that we have a right triangle, so we can use the Pythagorean theorem, and we can say 5 squared plus x squared equals 10 squared. That's 25 plus x squared equals 100. Subtract 100 from both sides, and I get x squared equal to 75. And now I'm going to take the square root of both sides, and I'm going to get x equal to the square root of 75. And that breaks down into the square root of 25 times the square root of 3. And the square root of 25 is 5 square root 3. So that length right there is 5 square root 3. So how are they related? This 5, if I double it, I get 10. And if I multiply it times the square root of 3, I get x. Let's see if that works again on the next triangle. So let's go ahead and draw in our altitude. And remember, we said they were equilateral triangles, so this is 60, 60, and this other one is 60, but it's cut in half, so that's 30 and 30. And we're going to go ahead and plug in. Let's go with 3 and 6 and look for the altitude here. Here's our unknown part, x right there. So 3 squared plus x squared equals 6 squared. 9 plus x squared equals 36. Subtracting 9 from both sides, I get 27. And if we take the square root of both sides of that, I get x equals the square root of 27, and 27 breaks down to 9 times 3. And the square root of 9 is 3 square root 3. So let's put our rule into a little bit simpler terms. If I have a 30, 60, 90 triangle, 30 degrees, 60 degrees, 90 degrees, then this side length, the short leg, is S. The hypotenuse will be 2 times S, and the long leg will be S times the square root of 3. Given a 30, 60, 90 triangle, what is the ratio of the short leg to the long leg? Well, we'll have the short leg, which is S, to the long leg, which is this S square root 3, and that reduces to 1 over the square root of 3. If we look at our other two that we had 5 and 5 square root 3. and that reduces to 1 over the square root of 3. And we can look at our other equation where x equaled 3 square root 3 and the short leg was 3. So that would be 3 over 3 square root 3. That also reduces to 1 over the square root of 3. Now we need to rationalize that, of course. So 1 over the square root of 3, multiplying the top and the bottom by the square root of 3 gives me the square root of 3 over 3. What is the ratio of the short leg to the hypotenuse? The short leg is s, and the hypotenuse is 2s. And when we look at that relationship, those s's reduce, so I get 1 over 2, which is 1/2. Does it work that way on the other triangles? We have the short leg being 5 and 10, so 5 over 10 equals 1/2. And here we had 3 and 6, so 3 over 6 also reduces to 1/2. Given a 30, 60, 90 triangle, what is the ratio of the long leg to the hypotenuse? So the long leg over the hypotenuse. Our long leg was 5 square root 3 over 10. 5 square root 3 over 10. We had 3 square root 3 over 6. So this reduces to 1 square root 3, which is just the square root of 3 over 2. This reduces to the square root of 3 over 2. When we look at our generic triangle, we would have the s square root 3 over 2s. Those s's cancel each other out and leave us with the square root of 3 over 2. The reason for this is that these are all similar triangles. Let's go ahead and formalize our 30, 60, 90 triangle theorem. Of course, we're always highlighting our theorems so that they're easy to find. And our 30, 60, 90 triangle says, in a 30, 60, 90 triangle, the length of the hypotenuse, is twice the length of the short leg, the long leg is square root of 3 times the short leg. So that means that if this is s, then this is 2s, and this is s times the square root of 3. Find y in each of the triangles. So this one is s, this is 2s, and this is s times the square root of 3. So that means x will equal 5 square root 3, and y will equal 2 times 5, which is 10. short leg here is y. The long leg was s square root 3, so I need to actually solve to find s square root of 3. So s square root of 3 equals 20. We're dividing both sides by the square root of 3, so I get 20 over square root 3. That gives me 20 square root 3 over 3 for the value of s. And I need to double that to get x. So this is y. This side length right here is going to be 20 square root 3 over 3. And that means that x is double that, so 2 times that would be 40 square root 3 over 3. On our last one, we know that this is our s, and our hypotenuse is 2s. So let's do 2s equals 32. Dividing both sides by 2, we get s equals 16. So this is 16. That makes this 16 square root 3. Go ahead and pause your video, do the try it, and come back and check your work when you're ready. Thank you for pausing your video. Check your answers, and if you still need help, please reach out to a teacher.